Hi, my name is Anahi Falder, and my statistic presentation is based around the following question. In the population of Americans who drink coffee, the average daily consumption is 3 cups per day. A university wants to know if their students tend to drink more coffee than the national average. They ask a random sample of 60 students how many cups of coffee they drink each day, and found a sample mean of 3.9 and a sample standard deviation of 1.4. Do they have evidence that their students drink more than the national average? Statement of the problem. The key issues surrounding the question are, do they have evidence that their students drink more than the national average? What test is used with this situation? What is the p-value? Will the null hypothesis be rejected? Moving along. Data collection. Amount of coffee cups consumed is a quantitative variable. Quantitative variables are variables whose values result from counting or measuring something such as a score on an exam or a person's weight. In this situation, random sampling methods were employed. Random sampling methods are a part of a sampling technique in which each sample has an equal probability of being chosen. A sample chosen randomly is meant to be an unbiased representation of the total population. A t-test compares the means of 2 groups, so in this instance, the mean for the national average of coffee cups is 3, and in this sample of the student's population is 3.9. On the right side of the screen, that is the formula being used. 3.9 is the sample mean, 1.4 is the sample standard deviation, 60 is the sample size, and 3 is the population mean. Next slide. Analysis. Null hypothesis. The amount of coffee consumed is less than the national average. Null hypothesis is a type of hypothesis used in statistics that proposes that no statistical significance exists in a set of given observations. Hypothesis. The amount of coffee cups per day is higher than the national average. A hypothesis used in statistics is a hypothesis that is testable on the basis of observed data, modeled as the realized values taken by a collection of random variables. Central limit theorem states that if you have a population with mean and standard deviation and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. So, because the sample population of 60 is greater than 30, we can approximate the sampling distribution using a t-distribution. This is a right-tailed test because we want to know if the mean in the sample is greater than the national average. A right-tailed test is where your hypothesis statement contains a greater than symbol. Results. I plugged in all the numbers into StatCrunch, and this is what the results showed. The t-stat rounded to the nearest hundredth is 4.98. The t-stat is the ratio of the departure of the estimated value of a parameter from its hypothesis value to its standard error. It is also used along with p-value when running hypothesis tests, where the p-value tells us what the odds are of the results to have happened. If the population mean equals 3, then the probability of taking a random sample of 60 and finding a sample mean greater than or equal to 3 is 0.00197528. Conclusion. The p-value is the probability of obtaining test results at least as extreme as the results actually observed, and since the p-value is 0.0001, there is sufficient evidence, and we can reject the null hypothesis as it is less than the significance level of 0.05. There is evidence to state the mean number of coffees consumed in the population of all students at this university is greater than 3. To conclude, the university has enough evidence that their students drink more than the national average. It is implied that students are consuming too much coffee, as it is higher than the national average of 3 cups. In the future, to improve my study, I could make the sample larger in order to more accurately represent the student population. Potential biases for this could include false information to save face as to where a student would lie because they don't want to admit how much coffee they have. This is known as a non-response bias. Not a large enough amount of responses, which is known as the selection bias, could have occurred, or students not tracking how much coffee they are actually drinking. This is an example of a measurement bias. Thanks for watching.